initial
Okay,
velocity he throws the ball?
And we're live. Is it
What do you guys want to
recording?
do?
Let's do little numbers.
Okay.
So pick a different number. Let's do 4.
4?
Then we can see the difference.
4 meters per second. This is negative 2 meters per second squared. Alright, so we're in a universe where our gravity is negative 2 meters per second squared. He's going to throw a football, and he's going to throw it at 45 degrees at 4 meters per second. Okay? So this is all parabolic motion. I know that when I throw this, as I see there, okay, that I have a velocity this way that is Vx and a velocity this way that is Vy. Now what will happen is Vx will stay the same until it's acted on by another force, which is when the guy catches it, right? And there's enough friction, he's actually stopped, like if the receiver was standing still there, he would just stop the ball by catching it, right? And so this right here would just be an abrupt stop. But that velocity going in the x direction never changes. Even though I'm going up and then coming back down, that Vx never changes. It's always the same. Because nothing else is acting on it, neglecting wind resistance. But footballs are designed to work with wind resistance and get more travel to them because of their shape, but we're just neglecting that. Now, however, my velocity in the y direction doesn't do that. As soon as I throw it, it's got a Vy, but it's a little bit shorter, little bit shorter, little bit shorter, little bit shorter, to the point where it becomes 0 right there. It no longer is traveling up. It completely switches directions and becomes traveling down. Little, little, a little bit bigger, a little bit bigger, a little bit bigger, until it's caught. So you guys see how y behaves very different from x. The velocity in the y direction is constantly changing. So as time goes on, do you have a change in your x direction? I'm sorry, your x velocity.
Yes.
No. Here's your x velocity. As time goes on, do you have a change in the x velocity? No. So that is a 0 change. It's the same when we work it out there, we have a number. It's the same number here, 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 all the way to the point he catches it. There's no change.
Net 0.
There is 0 change over however much time that ball is in the air, and change in velocity over change in time is acceleration. So is there any acceleration in the x direction? Not at all. Now let's look at the y. You start out at a certain value here, then it's a little bit smaller, a little bit smaller, a little bit smaller, a little bit smaller, all the way to 0. Then it goes negative, a little bit bigger 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 negative. Do you have a change in velocity in the y direction? Yes. You have.
Why is it negative after it hits 0 instead of just going back down? Or wait, no. Wait. Like why? You're not above the origin, so why is it negative?
Because remember, a negative in a vector is direction. So my direction of my velocity is this way.
You mean direction as in up and down versus like east
Correct.
and west? Okay.
So I do have a positive change, or in this case, I have a negative change in my velocity. My velocity constantly goes down. It goes positive this number. that number gets smaller, 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 smaller to the 0, and then starts going into the negative. So it starts out at a positive number, goes down all the way to 0, then starts creeping into the negatives. So this has a change, meaning that there is an acceleration. Now we know what that acceleration is. Negative 2 meters per second squared. We know that acceleration.
That's given.
That's
I
given.
just have that information.
Yep, that is given. We did not calculate that. That is just given.
So
Now you'll never see negative 2 meters per second squared. You'll see negative 9.8 meters per second squared. But we're just using simple numbers right now. So we have this change occurring in our velocity in the y direction. Do you have a question? Oh, okay. Did you?
So Vy is constantly changing according to gravity.
Correct.
That's what would, okay.
So the acceleration is changing also.
Acceleration never changes.
wait, we said acceleration was 0 and now it's -2.
Correct.
What happened?
We went from the x direction to the y direction
Why is acceleration never changing?
because it's always negative 2 meters per second squared.
But it's over time, and the time is.
Yep, so over time, after a second, 2 seconds, 3 seconds, every iteration, the acceleration is exactly the same. It absolutely never changes.
Well, it's slowing down, isn't it?
The velocity is, not the acceleration.
To accelerate is speed up, and it's slowing down, so acceleration. Am I just messing that up?
No, the speeding up and slowing down is your velocity changing. The rate at which your velocity changes is what we call acceleration.
Okay.
So this is constantly slowing down and then speeding up in the opposite direction. The velocity is changing all the time. Right? You jump out of a plane, you're going to continually, until air resistance makes you hit terminal velocity. If you have no air resistance, you keep falling faster and faster and faster toward Earth. Because your velocity would constantly change.
Okay.
At 1 second you're falling at this rate, at the next second it's a big rate, the next second you're never at the same velocity, it's always changing. And that means that acceleration is one value. Because that rate that you're changing your velocity is the same.
Okay, but if the velocity is changing, then that means the acceleration would change too, right? Because if in that equation, if the change in v is a different number, the answer's gonna come out different.
If this, remember, acceleration is the change in velocity over time, the time rate of change. So, in the first second, you fall 2 meters. Right? Go in your book. Remember when we first talked about acceleration in Module 1? It's Module 2.
Oh, it's a rate of change. So the rate of change is always the same.
Yeah, go to page 23.
Is that kind of like?
Still recording.
Yeah, it is. That's Erin, by the way. Can you hear it?
Oh, that's my friends at home.
I
So
can hear
if
it.
you're falling at negative 2 meters per second, the first second you fall 2 meters over 1 second. Second number 2, you fall 4 meters in 1 second.
Is that universal?
Right.
Right, so the rate of change is changing.
Correct. That's what it means. So you have constant acceleration here.
What's constant about that? Doing faster.
Right. You keep thinking velocity. Your velocity is getting faster.
I know, but it says the rate of change time rate of change of an object velocity. So the rate that it's going is.
Right, so if you fell 2 meters in 1 second, and then the next time you fell 2 meters in 1 second, and then the next time you fell 2 meters in 1 second, you have no change in velocity. So you have 0 acceleration.
Okay.
So if I fall 2 meters in 1 second, 4 meters in the next second, 8 meters in the next second, I have a constant acceleration. Every second, I'm changing my velocity by 2 meters a second.
But the
Or 2
equation that you're using is still it's still times 2 each time. It's not going from like 2 meters to 3 to 6.
So this would be, this velocity here would be 2 meters per second. This velocity here would be 4 meters per second. This velocity here would be 8 meters per second,
Okay.
right?
Yeah.
Okay, so you see how I have a change in velocity?
Yeah.
So a change in velocity over time is a constant acceleration. There's no change symbol in front of here. Your acceleration isn't changed. Now your acceleration can change, but here, if every second I'm going the exact same amount faster than the last second, then you're accelerating at a constant rate.
Okay, that makes sense.
Also, I have another question.
Yeah.
We said gravity's 9.86, right, for general.
9.8, yeah.
Yeah. Why can't we just use 10? Like in
Because it's not 10. It's 9.8.
But it's not 9.8 either, is it? Because that's rounded up. And wouldn't it just make everyone's lives just a whole lot easier to just teach it as 10?
I think a lot of high school physics, they do it as 10. This is Whitfield.
Yeah. Exactly.
This is
What's the
Whitfield.
basic
I want to be
acceleration
able to
again?
understand it though.
What's the basic acceleration again?
On Earth, it's negative 9.8 meters per second squared.
It's negative usually?
Always. Because most physics books mean up is positive, down is negative.
So when I'm just plugging in acceleration, it should be negative 9.8.
Plugging in.
As long as you make everything going in the up direction positive. Now, if you're dealing with a car going in X, Y, you gotta be careful, right?
So I should just put, if I'm making a little key for myself, I should put 9.8.
This is decelerating.
Okay, so.
It's getting slower and slower, but then it's getting faster and faster, but always in the opposite direction. Remember, vectors have to do with direction.
What was the one for feet per?
32 feet per second squared. All right, so let's look at the y component of this thrown football. How do I calculate the y component? If I throw it at 4 meters per second at a 45-degree angle, what is my y component? Good. My y component is 4 meters per second times sine of 45 degrees.
Vy equals 4n/s.
So, someone throw that in there. Yeah, meters per second
Oh.
times sine of 45.
2.8.
2.8.
So Vy.
And yeah, let's just pretend that this is 4.0, just for simplicity. That way we can keep two significant digits. So 4.0 meters per second, this becomes 2.8 meters per second up. So as soon as he throws it, this value right here is 2.8 meters per second. Is it higher or lower than that a second later?
Lower.
Lower. Another second later, is it higher or lower?
Lower, because they keep getting smaller until it reduces to 0.
Correct.
Can you find how much it decreases each time?
Why would we not see that?
Yeah, that's, we'll get to problems like that, where at any given time, you can calculate exactly what the acceleration, or exactly what the position, the time, and the velocity all is.
It'd be velocity that you're finding at those different times, though, right? Because your acceleration staying constant.
Yeah, you can calculate its position in the air, you can calculate along the x-axis, the y-axis, you can calculate the velocities at each of those points, the time of each of those points, how far you can throw it, what angle it hits the ground. There's a lot of information that you can calculate. In fact, that's how, if you launch a projectile, if you have a machine that can accurately push something out of a tube at a specific meters per second, and you can set the angle, you can calculate exactly where it's going to land.
Wow.
And this is how we shoot missiles and be accurate with them.
That's good.
Do they use that for sports though?
No, there's no way you can.
When we're not misidentifying who to missile.
You can't in sports, because when you throw in sports, you can't accurately down to this level hit that angle and hit that. That's all built off of muscle memory and experience, and just someone's ability to hit targets. Now, let's go like this. We're going this way.
No, we don't take breaks.
Now we are going to figure out. We're going to figure out how high it goes before it starts coming back down. In other words, how high does the football go? Well, at this particular time, this 2.8 meters per second is shrinking and shrinking and shrinking all the way until that y component is 0.
Do I know my initial acceleration?
Your acceleration never changes. It's negative 2 meters per second squared always.
Yeah, going up.
It's negative 2 meters per second squared.
That was 9.8.
So
That's-
you guys wanted to use
Oh.
easy numbers
Okay.
and do one without 9.8. But normally, yes, this would be negative 9.8. So your initial acceleration is this, your final acceleration is this, your acceleration before you did this is this, your acceleration after you did this, the acceleration is the same. That never changes.
Yep.
Your initial velocity is 2.8 straight up. It's also 2.8 out there. And at this angle it's 4. So, here, my final velocity in the y direction is 0. My initial velocity in the y direction is 2.8. So I can use my equation, final velocity vector squared is equal to initial velocity vector squared plus 2 times acceleration times delta x.
My initial acceleration in my y direction. Correct.
This acceleration in your y direction.
Sorry, my initial velocity in my y direction.
Your initial velocity in your y
So
direction.
this example gives you 15, but that's in my 45 degree.
That's in your 45.
So you're always going to use initial when you find your y.
Correct.
Can you use your 45 at your angle acceleration? Sorry, 15.
Not right now, but you can.
You can. Okay.
So, my final velocity in the y direction is 0. My initial velocity in the y direction is 2.8. My acceleration in the y direction is negative 2. And I'm solving for my distance in my y direction. So I subtract this from both sides, and I have negative 2.8 Okay, so this will be negative 4. I'm going to divide both sides by negative 4. .8 squared, someone throw that into a calculator real fast. 4.16 or something.
7.84. What?
Be more than that.
Maybe I did the ready for
2.8.
2.8 squared.
7.84.
Yeah, that's what
Oh yeah, that's right.
I think you're thinking 4.
I'm thinking of 4, sorry. So 7.8? Is that what you said?
7.84, but yeah.
7.8, and that's going to be meters squared per second squared. remember, because I square everything inside, and that's negative, over -4 meters per second squared. The negatives cancel. What's 7.8 divided by 4?
1.95.
1.95 becomes 2.0. Alright, then your second squareds cancel, and then your meters here cancels out with one of your meters there, and it's 2.0 meters.
And that's the height of it.
That is this height, okay? What we calculated, guys, was how far it took to get there.
Okay.
That's what we calculated.
And that is what they want, that is the maximum height that it will reach.
Correct.
Okay.
So if that's the case, then that means that the x displacement is also 2.
Do what?
The x displacement is also 2. I'm not giving it, it doesn't look like that, but
We could calculate the x displacement.
but wouldn't it be at, there wouldn't be 2.
Otherwise, it'd have circular motion. You don't have circular motion, you have parabolic motion.
Oh, so it's a
So,
radius
yeah,
of
so
6.
what is my Vx, Aaron? What is my velocity in the x direction?
4.8.
Yes,
4.8.
4.0 meters per second times cosine of 45 degrees, which is also 2.8 meters per second, right? Okay, so then, did you have a question?
Yeah, but Aaron can go first.
Okay, so then, Aaron, if I want to know how far it travels,
In my x direction. Well, I guess it would be half the distance between the layers.
we're gonna have to solve for time, because what we're gonna see here, Aaron, is that if we look at, okay, my initial velocity is my final velocity is still 2.8 meters per second, because that doesn't change. That's equal to my initial 2.8 meters per second squared, plus 2 times acceleration is 0 in the x direction, delta x. So this becomes 0, this and this cancel each other out, you get no information from that equation. So we're gonna have to figure out time if we wanna do anything in the x direction.
You squared 2.8.
And you did over here too,
Like, do you just?
because your final and your initial are the same.
Same.
So they cancel each other out. This 0 makes that go to 0, and you just have 0 is equal to 0. It's not interesting. All right, yes.
Could you, so using the information, could you also use sine, cosine, and tangent and like the law of sine and stuff to find it? Because we've already got the angle and, nope, actually.
Keep
Wait,
going.
how does the displacement work out?
We have a speed of 15.0, but I thought we had the distance. I made a mistake. So we just have the angle. If we had the distance, we could find it because it's just the, yeah,
Right, so you just solved this distance,
yes,
right? And you know that
we don't.
this angle is 45,
Yes, that's all we know.
and you know this distance here.
Well, that's what I'm saying, if we didn't know what that was, but I thought we knew the distance the field was, but never mind. I made a mistake.
You're good.
Could we take a 5-second break?
Trust minute.
1, 2, 3, 4, 5.
Yeah, we can do a 5-minute break.
Aaron, pause your.
This video is gonna be all over the place. They're gonna be like, wait, what happened?
Hey, Audrey, did you pause it, please?
What?
Can you pause
You're
it,
just gonna have to
please?
stop it and
Did
start.
I
a new
apply
one.
for what?
Can you pause it, please?
I'm sorry, what?
Can you pause
I'll
it?
do it, Aaron. She can't hear you.
Can you pause it?
Oh, she
Pause the
can't
video.
hear. We're just gonna stop it.
It's on the far end.